Hey, hi friends. Good evening, everybody. Welcome back to the session. We are connecting here today, second day, day two, to try and understand how analytics can be implemented in the agricultural sector. So we're talking about agriculture analytics, or you can also say smart farming. You can say farming analytics. And as part of the discussion yesterday, I have tried to bring up some of the use cases that are being implemented in the sector, and couple of the examples, in fact, more than couple of the examples where I was personally involved in these projects. Now, as part of today's session, we will be trying to understand the implementation of a solution by taking the data that is getting generated from the agriculture sector. So how do I actually bring up a model implementation is what we are going to try and understand. So in short, I'm trying to explain today on what are various steps that we'll have to use or follow if you are trying to develop a solution in the space. Just like any project, we will also have to follow a specific standard format for a use case that we are trying to develop in agriculture sector. If data gets involved, then the data analytics projects by default worldwide, we used CRISP MLQ methodology. When I worked on the projects previously, the CRISP ML methodology used to be called as CRISP DL. But there are certain practical challenges. Of course, we also had to face those. And based on the best practices, the process also got evolved. And now we are talking about CRISP MLQ methodology. So what exactly is this CRISP MLQ methodology, and how we will be able to implement the methodology in practical sense? So the CRISP MLQ methodology is basically standing for this. The abbreviation is cross-industry standard process for machine learning projects. And also we have to ensure that the quality is maintained at each and every step of the product development in this process. So the Q stands for quality. Cross-industry standard process for machine learning projects. This basically means these sequence of steps that you are seeing here, the series of steps that we are showing here, these are going to be the de facto steps for data science related projects, analytics related projects, irrespective of what industry we are talking about. Whether it is agriculture, that is what we are going to talk about, or whether it is, let's say, supply chain, life sciences, healthcare, manufacturing, retail, logistics, you name it. You talk about any industry, if you are trying to work with the data, and if you are trying to develop a solution using the data, then this is the standard process that we have to follow. Universal. And it contains 6 phases in the life cycle. The first 2 phases, the first 2 steps basically are coming from the first phase, which basically speaks about understanding and coming up with a plan. This is planning phase. For example, there's a business problem. Farmers are not able to get optimized price for whatever the crop that they have cultivated, and then they want to sell it, the crops, right? So when they're doing it, they are not getting enough revenue. So the business problem that we need to understand here is, how can we ensure that the farmers get profits with respect to the finished product sales? I mean, finished goods, right? Whatever is the cultivated crop, the yield, we want to ensure that there is good price given for that particular vegetation or the yield. How do we ensure that we can give good price? So we need to understand the exact requirements. If I have to give profits to the farmers, the scenario that we are looking at is, the farmers have already cultivated the crop, and they have the right cultivated vegetation at hand. Now they are trying to sell it. If they can get good market price, good value, then obviously they are going to get profits. Now we need to understand the requirements, right? You cannot say that we need profit, so you try and right, increase the price and sell it. That may not practically be possible every time, because these products that we're talking about, the vegetations, the fruits, vegetables, they have more or less kind of a fixed price based on the season, based on the time. There will be slight variations, but if, let's say, the vegetable is tomato, example, if the market price says 20 rupees INR per kg, then you cannot say just because you want profits, you sell it for 30 rupees. Right? That is not an ideal solution, because practically nobody is going to purchase from you. If you're the farmer and if you're trying to sell it for 30 rupees per kg, when the market rate is 20 rupees, nobody is going to purchase, right? So how do we address this particular problem? Okay, so try and understand the requirements. The requirements basically says we need profit for the finished product, right? Or the cultivated vegetables. We want to sell it after the crop is done. So that is the situation. Now, the primary objective of our task, the goal of our task is to try and maximize the returns. Maximize the returns. How I can do this object? How can I achieve this objective? There will be constraints, practical challenges when you're trying to develop a solution here. Lifespan for the vegetable is always decreasing, right? Lifespan is less and the product always depreciates. As the time passes by, the quality of the vegetable is coming down. So there is lack of time. Okay, that is first thing. Second thing, we also have to look at the transport cost, because the farmers have to transport the entire vegetables or vegetation that they have cultivated to the market, right? So you cannot simply say export it so that you get more price. Now, how much cost do you incur if you are doing the export? Is that really worth? Is something that you also have to look at, right? So transport cost. The another challenge is the market rate. More or less, the market rate will be kind of a fixed price, right? The government of that particular location is fixing, right, a price. This is automatically done by the syndicate group. This market price is fixed, more or less, with less variation. Next, the season. We are talking about the time, the sales, the demand for that particular product. So a lot of such constraints would be there when you want to say maximize the returns. Considering all these challenges, we'll have to find a solution. So if you are trying to give the optimized solution, then the solution has to consider all these challenges also. So you have to document everything, right? You have to try and analyze the situation, do the market research, understand how the business is actually done, what are the various steps in this process, and document all the challenges that we might see through. It's a planning phase, right? So we keep documenting this, as in how we uncover more hidden facts. We keep documenting them. And once the documentation is ready, this would probably give us a more concrete idea, better idea, to proceed further in developing a solution. Right? So here we will also have to think from a practical perspective on what data we will be using, where this data coming from, what all fields we will have in this particular data in order to find a solution with respect to the project, the objective. So as a simple example, in this particular case, if I have to maximize the returns, then maybe I want to understand upfront on what could be the cost of that particular vegetable given day, or probably next day, or whatever the day that you're planning to reach the product, reach the market with that vegetable. So what could be the cost on a particular day? Now, if I know the historical data, I will be able to identify the price. And there are a lot of government portals where, right, community portals where the historical details are all recorded. Right? Price, daily, on day-to-day basis, what will be the price? Now, this price is not fixed pan-India. There will be different mandis, right, markets, and there will be slight variation in the markets. It may not be too much, but it will be little here and there. So we want to ensure we also get the price or the cost of that particular vegetable from different mandis, which probably are within a specific radius, which you will come up with by looking at the cost associated with the transport. Right? Cost and, of course, duration, the time to travel. Cost and duration for transport. So assume if you say that, hey, 50 kilometers or maybe 150 kilometers, there is no problem. Assume, just as an example I'm telling. So from the farming land, we will be able to reach up till 150 kilometers range, right? Whatever the radius area is, within 150 kilometers, what all different mandis or markets are there where we will be able to sell this particular product or vegetable? And what is the cost of this particular vegetable in those markets? This will basically give us an idea on the investment and the returns, right? But if I can also plan on what would be the cost of the product after 2 days, future dates, right? If I can also identify that, then this can basically allow the farmer to plan to reach the market on that particular day. Considering the season also, considering the climatic conditions as well, considering the demand, right? All these things. So the solution that we can think of here is, from a prediction perspective, predict the cost of the vegetable on a specific day. If I can do that, then I will be able to take an appropriate decision. Right? So this is the solution that we are eventually trying to build to solve this problem. But now, how do I implement it? We understood the scenario, we understood the objective, we also planned how what we need to do. But how are we doing it? Because when you talk about historical data, the data is not readily available for us. Isn't it? Nobody is going to give you that data. So we will have to get the data, right? Data extraction has to be done. In this particular use case, the data can be extracted from public portals. These portals are managed and developed by various communities, public communities, government bodies, NGOs, and they record all this data, right? So there are publicly available portals where the data is available. So we will be doing web scraping. We will have to try and build web scraping models. These models should constantly look into the sources and then keep getting the data. So it should be a continuous process. And you can decide on the interval where this particular script can be triggered to get the incremental data. You don't want to scrape everything. Maybe I'll say that, hey, we have 5 years of data. Right? So we identified certain websites, let's say website 1, website 2, website 3, website 4. Assume. Okay, 4 websites is what we have identified where we thought relevant data is available. In short, we are talking about the vegetable and the cost per day. So for all the 5 years, we have this information for different market. Now, if I have this small information available on day-to-day basis, if we can capture the data from these multiple portals, then using this information, I can build a model. But as I said, web scraping algorithm has to be developed. And continuously, this data has to be keep collected. Continuously, it has to run. Now, the model that we are going to develop, the solution that we are going to develop is going to look into the old data. That is nothing but your historical data. So let's say till July 2022, we are collecting the data. Right? Using this data, we will have to try and represent a model. When I say model, it's a mathematical expression. Y is equals to f of x case. Y is your output, the variable of interest, and x is the factors that are influencing the price. So here in our case, we are talking about cost per kg. And the x is the day, the date basically. And then the location, the market. Probably you can also talk about the season and other factors which could influence the price. So if I can express the condition, the scenario on mathematical front like this, mathematical equation, then using this equation, we will be able to do the prediction. We will be able to do the prediction. Right? So step number one, we understand the requirement, business logic, and we also understand what kind of data we will have to work with. Once this gathering is happening, the requirements gathered, we also do planning on how we want to develop the solution. We need to identify the sources where the data is coming from. We need to identify how you're going to get that data. We need to identify what kind of challenges the data might have. We need to also identify what algorithm we might want to develop. We also have to plan on how the end result is going to be given to the end customers. So once this entire planning is done, we proceed further in implementation. So till here, we do planning. Once the planning is done, we get into the action, we collect the data, we run this script, web scraping script that probably you'll have developed. And then once the data is available, we will have to check for the various challenges that the data might have. There may be a scenario where the data might have not recorded on a specific day. Could be a problem, right? Could be a scenario where data was not collected. Or maybe there could be some scenario where the data was recorded, but it got corrupted. So in the backend, the data was not able to, the web scraping algorithm could not get that data because of the corruption. This is with respect to missing scenario, missing data. One or two cases where we are not finding the data. So what we might want to do in this case? This is a challenge, right? So in this case, if I have only one or two cases which are missing in 5 years data, we're talking about 5 years, day on day, right? If I talk about 365 into 5, you get a big number of data, right? Huge amount. So one or two cases missing is fine, isn't it? If you have a lot of data, then you'll have to come up with a appropriate strategy. In this case, what we can do is we can take previous day's price and just add it. If the data is missing here, you just take previous date price and add it. If you want to be more confident, probably you'll take previous and next day's data, take average of these two and then update. So this is one strategy that we can employ. This is how we deal with data which is missing, right? So missing data is represented as NA. Either you substitute this or substitute this, or take both the values and then do average of that. Very simple. What if you are seeing data, the rates in such a way that one specific rate is like very, very high on a one specific day or a sequence of days, we see that the cost of that particular vegetable is very high. It's an exceptional case, right? So if you see these kind of exceptional values, then what would you do? So in such cases, we need to try and investigate on what happened that particular date. We'll know the date, right? On which date or dates the price was increased suddenly. So we will have to go to the historical data on that particular date. What exactly happened? You can refer to the news channels, you can refer to the online portals. There could be a lot of forums where the discussion might have happened. So if the price is suddenly increasing, then there could be definitely some reason that we need to identify. If it is a genuine case and if it's like a pattern that we are observing, then we can have that price as is continued. But if you feel that this is some kind of a one-off scenario, right, very rare case which probably may not happen, in such case, you might not want to consider these exceptional cases. You might want to have some regular prices updated. Right, so this is another way to deal with exceptional values. We call this as outlier treatment or exceptional case treatment. Then in this particular scenario, we have date. Python is the programming language which is probably used now in the entire world as the first choice for developing machine learning models. But Python will read the data as a string. That means, in short, we are talking about this as non-numeric data. Because ultimately, I want to predict the cost given the date, given the location, and other factors. So in this case, if this is the date, which is a non-numeric format, right? If it is non-numeric, then obviously you'll not get any right computations done here, right? If non-numeric values are there, you cannot finish the mathematical equation, right? So in this case, you might want to represent this non-numeric date on a numeric values. We are talking about daily key scenario, day-wise, right? So when we talk about this day-wise scenario, the data is always in sequential, right? Days will be in sequential order. You cannot collect the data in random order, right? If it is a date-wise data, then it has to be in sequential order. To convert this days, we will be using an index, which is nothing but a sequential number, like 1, 2, 3, 4, 5, right? Like this, which represents the day. Right? So this is to ensure that we're representing the days on a sequential number. So we are converting the string data into numeric format. So on and so forth, there will be various other challenges that we might encounter. So we'll have to try and address those challenges, which are logically being justified for that particular business case, for that particular scenario. Then comes the actual machine learning algorithm implementation, the next phase, right? Next life cycle is machine learning implementation. So here we are doing the planning, here we are doing the pre-processing. We call it as pre-processing and trying to understand the data more from a business perspective and more from a programming perspective, technical perspective. So we do pre-processing and ensure that the data is ready. Once the data is ready, we will be using machine learning for doing the processing of the model. But what you need to understand is your machine learning models that we talk about are broadly classified into two types: unsupervised learning and supervised learning. The unsupervised learning is also known as descriptive modeling. There may be a case where you might want to group the data, cluster them, right? We're talking about the price, the location, the date or the time or season, you can say, the demand for that particular vegetable or vegetation, right? So on and so forth. Now, if I can try and take all these records, maybe we will see some kind of a pattern which talks about similarity, right? So there might be some specific behavior which basically probably give us a hint that all these records are kind of giving similar values. So under unsupervised learning, we are trying to do grouping. And when you group this, you always try and remember that we are trying to group similar records, right? The records which are very much similar to each other. All right. This basically will allow us to extract some information readily available, right? Information from the entire group. When I say similar records, the characteristics of all these values will be similar, which eventually will allow us to understand the characteristics of that entire group. Right? So if I can create these groups, I don't have to further drill down and look at each and every point, not required. If I know what group would be appropriate for a given scenario, I'll directly go to that particular group and then look out for individual records only from that particular group, not from other groups. Right? So this is one example of unsupervised learning. We also have something called as association rules, or we also call it as frequent pattern mining. We might want to take additional information from the public portals that is available. If I want to talk about a specific market, this market maybe is popular for specific kind of vegetation. Generally, all the farmers who cultivate a specific vegetation, they try to sell in that particular market. So it is like popularized for a specific product. For example, you talk about oranges. They're very popular in Nagpur, in India, right? So a small example. So we want to identify such characteristics with respect to the markets. This is more of a generic or you can say popularity-based information. But how about trying to identify that if you have a specific vegetable that you are trying to sell, then this vegetables may get sold if it is going into a market which also is selling a specific other vegetable. Or in the other way to interpret this, if a customer, right, is trying to purchase this, maybe they also prefer to purchase the other vegetable. So we're talking about the association between the vegetables. This would try and give you a better chance of getting your vegetable or your vegetation sold for an appropriate price. The chances increase if you can identify these associations and try to plan your sales with respect to that particular plan. Associate it with other products. This is also part of your unsupervised learning. Okay, we may try and strategize some solutions from analyzing all these opportunities. Then comes the supervised learning technique. This is where we do predictive analytics. Predictive modeling comes into the picture. In short, we are trying to develop a mathematical expression like this. Your output can be expressed using a mathematical model, where Y speaks about the price, or we talk about the cost associated with respect to the product. The input that we are talking about, the X, this is called as output. And these are called as input values. Multiple input sets could be there. right? So here we are talking about input. The inputs could be date, the demand, the location, the time. You might also want to look at the delay. When I say delay, we are talking about how many days the vegetable is in the market or will be in the market after it gets, right, the what do you say, the cut from the market. Once it is plucked from the market, from the plants, how many days it is there in the market, because it has to be sold immediately, consumed immediately. Otherwise, there will be delay. There will be quality depreciation, right? The life cycle of the vegetables are very less. So this delay is also going to impact the price, right? The climatic conditions will also be there. So on and so forth. There are many such scenarios which will impact the price. We bring in all of that and we create a mathematical expression, something like this. For example, I'll say y is equals to ax1, bx2, cx3, so on and so forth, dx4, ex5, so on and so forth. Right? So this is your mathematical equation or expression that you are trying to create. Now, if I can successfully bring this equation up, then I will be able to do the prediction. But there's always a challenge with respect to accepting this equation. We're using this equation for doing the prediction, right? That means we are mathematically trying to estimate a value which we don't know or which is going to happen in future. And using that calculated result, estimated result, we are going to take an appropriate decision which is going to impact the outcome. But can we trust the prediction value? Can we trust this? Right? We need to think about this prediction case. So whatever the equation that we are getting, in short, is this equation giving us correct value? Is the prediction being correct? This is something that we will have to analyze. Now, in order to analyze that, we use certain techniques, evaluation techniques. These evaluation techniques are again further classified because your supervised learning techniques are further classified into two segments. It depends on what is this value that we are trying to calculate. So from a programming perspective, mathematical calculations perspective, is this value that we are trying to calculate in the equation is going to be a numeric value? For example, here I'm saying price. What would be the exact price of that particular vegetable? This is a numeric calculation. But what if the value is a non-numeric case? Whether the product will get sold or not in the first place, right? So this is also something that we might want to look at. Non-numeric case, yes or no, binary scenario. If the output variable that we are trying to mathematically calculate, if it is going to be a non-numeric case, right? Or for example, the quality, we have to identify the quality of the product given various constraints. The quality could be poor quality, average, and good quality or premium quality. The price of the vegetable will vary based on the quality of the particular outcome or the vegetable, right? So you want to identify the quality. So here we are doing a non-numeric calculations, isn't it? So depending on what we are trying to do the prediction, the value that we are trying to predict, the algorithms are further classified into two types. One is called as classification technique or classifiers. The other ones are called as regressors or regression technique. So if your value is numeric in nature, then you can simply do a mathematical calculation. We get regressors or regression techniques which will be used. And because you will get a numeric outcome, this is called as predicted value when you see the hat. We also want to know whether this predicted value is a correct value or not. If not exactly correct, but how correct it is, how much deviation we have in our prediction, we might want to measure that, right? Measure the accuracy, measure the performance of your model. So how correct is this calculated value? But unfortunately, we will not be able to measure it for future predictions. Because unless until the incident happens, the actual event occurs, we will not know what is the actual value. We'll only have predicted value based on which we are taking certain decisions. So we cannot evaluate. So what we do, we look at the historical data and we will hide some data. We hide it. We call this as test data. So we are basically hiding this and use this particular test data at a later stage. So using the remaining data, which is called as training data or trained data, we will develop the machine learning algorithms. It's nothing but a mathematical model that we get. Now what we say is, hey, this is new data. The test data that we have, we will assume that this is new data. So I will pass input to this equation that we have developed here. And then when we pass the input to this equation, we will get the predicted results. But because this is historical data, we also know what is Y. It's just that we have hidden it, right? So using this Y, we will try and measure on how good is the prediction here. We'll try to see what is the difference in our predicted value when compared it with the actual value. This is actual value and this is predicted value. This is called as error. Predicted value minus actual value, we get error. Lesser the error, that means the predicted value is closer to the actual value, right? So better the prediction. This is a technique that we will use, a metric that we will use in order to evaluate the model's performance. If you see a lot of error here, the error is large, very high, then we can adjust this model. This adjustment is done using a tuning technique. By altering the options that we are passing to the machine learning algorithm, right? We call them as parameters. We keep altering or tuning this particular parameters. Thereby, we are adjusting the performance. We keep doing this until we get a satisfactory result. This is from a regressor perspective. If I have the same historical data, the process remains the same. We are hiding some data. We call this as test. We call the remaining thing as train. But in this specific case, if I try to predict a non-numeric value, then we are calling this as classifier model, classification technique, or classifiers. We're bringing this classification technique, right? So when we talk about this classifier, the outcome is non-numeric, right? So I cannot calculate the difference like this. This is something that we cannot do. I have X, I have Y also. I got the predicted values here. I'll get predicted value. I also have actual value. But because I cannot do this calculation directly because of non-numeric nature, what we can do is we compare. We can do the comparison. Assume I'm trying to talk about quality. Okay, assume this is an example. Quality of the vegetable. When you talk about non-numeric, there are categories. The quality can be categorized as poor, average, or good. So I have three different categories. I cannot have any other category. Okay, there are only three possible outcomes in my output variable. So if you're taking a specific vegetable and if you're trying to say, hey, this farmer's vegetables are of good quality, right? You're trying to do the prediction. Okay, predicted value is good. You might want to compare this predicted value with the actual value. In the historical data, we already know what is the quality. Right? So we will do the comparison. If the actual value is also good, this is actual value. If you do the comparison, then these two are equal, right? So I will get true. That means the prediction is correct. But if the output variable is, let's say, average, assume the actual value says it is average. But what we predicted was, or what we identified was good product, good category. So our classification model says that the product is good. This is your predicted value. The actual value is average. Then if you compare these two, they are different. So I will get false. So either I get true or I get false as the outcome. When you're doing the comparison, whether these two are equal or not. That's all. We are trying to understand that. If they are equal, that means the prediction is correct. If they're not equal, the prediction is false. Wrong prediction. Total correct predictions is what we want. That means true predictions is what we want out of all the predictions. So here we will be able to measure accuracy. Number of true predictions by the total number of predictions. All the total number of predictions. This is going to be your accuracy measure. If I talk about mismatches, that means false cases, then this gives us the overall error rate. This is the accuracy rate. If I take all the false cases out of all the true total predictions, this is nothing but overall error rates. Right? This is overall accuracy. Right? So this is how we try to evaluate the models, the machine learning algorithms. And what we tend to do is we try and, right, if I say continuous, this is different error calculations. We try to do the error calculation. If it is discrete, that is categorical data, then we have something called as cross-stable or confusion matrix. And we get true positives, true negatives. Accuracy is nothing but total true cases divided by all the total values. Right? So this is your overall accuracy. So this is how we do the calculation. And once these calculations are done, we do comparison of the performances for both the training data and test data. We compare. So if I talk about this historical data, I said this is your train data and this is your test data, right? So you will use train data to build the model, and then you are evaluating how this model works on the training data itself. So here also we will get performance measured. And here also we will do the calculation, performance calculated. We compare these two. And if the performance is similar, right, if they are close to each other, then we call it as right fit. For the consistency, we call it as right fit. But if the model works very well on the training data, but it fails miserably on test data, then we call it as overfitting. That means it cannot generalize. Unknown data, it is not able to work properly. The model is not working properly on the unknown data. It's not a good sign, right? So we'll not be able to use that, or we should not be using it. If the model does not work here itself in the training data itself, then it is called as underfit. That means the training is not sufficient. It did not learn. The model did not learn the pattern. This is called as underfit. So these are different techniques that we will use in evaluating the models. Once the models are tested, once we are satisfied with respect to the end result that we are getting in the evaluation process, we choose the best model. Right? Ultimately, we are doing this. Once we are satisfied with the model's performance, we use that particular model, which is also known as the best model, for deployment. That means use. You allow the end users to start using the model, right? The mathematical expression. Now, you might want to ensure that you give a proper user interface to the end users, because they are not Python programmers or not technically equipped people. So you might want to give a very simple mobile application or a web application where they open the computers or smartphones and then give the inputs. So users start using it, but you'll have to try and have a user interface, preferably HTML format, and then start allowing the users to use it. This information will become our feedback, right? Whatever the model right, we are finally giving, it starts doing the predictions and we get the end result. But that end result, when the actual incident happens, we will be able to identify whether the model is working the appropriate, right, expected way or not. If yes, if it is working on the expected way, then we stick to that particular model and keep monitoring. Constantly we keep monitoring, because there will be drift, right? There might be some changes in the business line, right? The government policies could impact the overall outcome. The recession could impact, the seasonality could impact. So there could be various things which basically impact the overall business case. In such cases, the model that we have developed may not be appropriate. Right? So, yeah. We keep tracking that, And if there are any changes required, if the actual business case is drifting, then we will actually use this difference or the change that we are observing to ensure that the model is also adjusted to address those changes. So we have to keep monitoring, and whenever it is required, we keep altering it, right? We start maintaining the model. So maintenance is nothing but we keep tweaking it. So based on the feedback that we get, when I say feedback, it is the results that we are getting from the model, we will be able to monitor, understand the changes, and then implement those adjustments. And this is an ongoing process. Hence, we call it as life cycle. Right? It constantly happens, keeps on happening. This is how your CRISP MLQ methodology is implemented. Hope you have got good insights into the process, the life cycle, the product development life cycle. There are various other finer details that we'll also have to understand. Next week, that is on Monday, we will try and connect back and then discuss about one of the use case implementation. We'll talk about very simple use cases, but we will try and use some of these data mining concepts, machine learning concepts to solve the business problems. So we'll do the practical case, right? Hands-on. Hope you keep enjoying, keep learning. See you soon on Monday. We will again connect back. Until then, thank you so much, friends, and enjoy your weekend. Have fun. Keep learning. Take care and good night, friends.